Hey there, everybody. The purpose of this quiz is to get us some solutions to the hypothesis tests for the soda can problem. So we've got a random sample of some volumes of soda cans that are supposed to contain 12 ounces, and we are trying to see if we are hitting an average of 12.1 or more. If they are below 12.1 ounces, we got to recalibrate the machine. So a real quick look at the ounces show quite a few that are hitting 12.0. That makes me a little bit nervous. So we're going to go ahead and we're going to crunch the numbers. There's a 12.1. There's a 12.5. Anyway, so we're going to crunch these numbers through the hypothesis test to see if we get statistical significance, which, as we've discussed, is different than practical. But without context, all we can do is statistical. All right, we are going to be testing mu for sure. And the mu that we are interested in is going to be the average volume of a 12-ounce soda can. That's going to be our average. Now, we are concerned if we end up with a mu that is less than 12.1. That is definitely the concern here. If we can support that hypothesis, then we've got to get in there and we need to recalibrate the machine. I don't know why I just said it like I was a robot. The null hypothesis for that, let me see if I have this symbol. There's a greater than, or there it is, greater than or equal to 12.1. So that's the two hypotheses we're going to be testing. All right. So next up, what are the possible types of errors? Well, type 1 error would be a false positive. That's saying the machines are filling to less than 12.1 ounces when they actually aren't. Let's make that red so it stands out. There we go. So it's kind of strange. Saying the machines are filling to less than 12.1 ounces when they actually aren't filling to less. So that would mean they're actually filling correctly, which is it's a strange double negative way of saying it. So that's a type 1 error, false positive. Type 2 error, false negatives, saying the machines are not filling to 12.1 ounces when they actually are. So nice doing these things in a computer, so quick to copy and paste. Which type is worse in your opinion and why? I mean, it depends on what you think, right? A false positive, if you choose false positive, that means that you think the cost of a recall is prohibitive. So for whatever reason, okay? But if you choose type 2, you think that somehow letting underfilled soda out into the environment is a bad thing. Maybe in America it is. Americans are often sue happy. So it doesn't matter to me which one of these you guys put, as long as you give a nice reason for what you did. It's an average test, so we're doing a t-test for sure. Test statistic, correct variable, and p-value paired with that. Okay, so I'm going to cheat a little bit here because I really don't feel like putting these values into my TI right now. I'm going to see if I can't do this in Excel. Will it let me? Oh, it sure won't. Well, there's the values right there. Okay, it kind of did. So I'm going to cheat a little bit, friends. I'm going to show you a cool little Excel cheat here as well. Let's delete all these. I have no idea why it just pasted like this, but we'll go delete. We'll scooch up. So here are all the data values from the table. So what I'm going to do is equal average. You know, if the TI was a logical thing, it would allow you to copy these values into your TI, like any other good software would do. Equals stdiv. If you took me for 243, these are the same commands you would have used back in your during your first exam, most likely. Okay, so we got a standard deviation. There's also a cool little command called count. It lets you know how many items are in a list in case you don't feel like counting. So we've got 35 items in the list with an average of 12 point that and a standard deviation of that. So what I'm going to do is I'm going to get my TI right here. Oops, not that one, need the other one. The actual, right there. Nope, that's once again the wrong one. We need this. There he is. As soon as this will go away momentarily. We're going to fire it up. We're going to run stat tests. All right. Now, we've been using, oops, I grabbed the wrong one. Tests, Ttest. All right, bring this front and center here. Now, we've been using data quite a bit in class. And if I had put these values directly in, we would still be using data. But we're going to use stats this time. And what this allows you to do is it allows you to put the statistics down here. So for example, for the average, I can put in 12.14857. And for the standard deviation, it allows me to put in 0.204898. And for a sample size, I can put in 35. So it gets you the same thing as putting the data in and running it that way. We're testing against an average of 12.1. And we are trying to see, scroll down here, we're trying to see if we fall in less than that. And I know you guys like to draw, and I do too. And there it is. Whoa! Okay, so we're trying to see if it's less, and this sure does not look like it's less. It sure does not look like it's less. We got a lot of p-value. As a matter of fact, if you look at the test statistic, it fell far to the right, which means not only are we statistically coming in under 12.1, as you can see from the average, we're actually coming in above 12.1. So if you go back to your TI, so your test statistic is 1.4. Yours might vary from that a little bit if you ran the TI. I've got some truncation issues here. So let's go back to here. We get a t value. T equals 1.4 approximately. Make that red. And the p-value is about 91%, which is a humongous agreement with the null hypothesis, yeah? So it does not appear that the cans are being underfilled. Now, that having been said, let's just finish this off. Not undefiled. Underfilled. There we go, which I'm sure it won't like. Okay, so now since it's a negative test result, we could have made a type 2 error. So if you want to avoid a type 2 up here, you might want to lower confidence. But I'm not that concerned about that. What I'm concerned about is just the overriding result that we got. How could it be that we got such a huge p-value when your data itself, from the original scanning of the original data, which I now can't find, hang on, here it is, has so many numbers that are under 12.1, 12.0, 12.0, 11.9, 12.0, and so forth. I mean, if you go back to the original data, let's do it. So just so you know, we're done the quiz now. We're done the quiz, and I'm going a little bit deeper because I like doing this sometimes. So look at this. How many of the data points in the data set are below 12.1? Well, most of them. Look, you've got 19 data points out of 35 are under 12.1. So how could it be that the average is above? Well, we're going to go a little bit deeper here. We're going to go a little bit deeper. Are the data relatively bell-shaped? Well, let's just do the real quick. I'm going to do a real quick rough and ready. Where's the add-ins? Is it under data? We can do a real quick data analysis. Yeah, you can generate a histogram. We're going to input range this. Okay, we're going to see. I'm just going to go ahead and let the Excel drop it wherever it needs to drop it. Okay, so there's your frequency. Look at that frequency, 1185461. If you think about that, if you were to graph that, which we can do right here, I'm just going to make up a new value here. Hang on one sec, just to get a picture of this. Beautiful. And we're going to do a real quick chart to get this is a real rough and ready histogram, and the only reason we're doing this histogram is to get an image of the data. That's probably what's going on. You've got quite a bit of skew in this data set. It's getting kind of hard to call this bell-shaped, right? And even if you were to run a skew command, equals skew all this data, this gives you a measure of anti-bell-shapedness. Yeah, 1.033. You're starting to get into that territory of skew that might affect the average. Okay, we're getting a little bit subjective here. So that might be a way of explaining away why the average is above 12.1 when in fact much of the data is not. So anyway, that's why you have to take it with a grain of salt. Yes, statistically significantly, there's no reason to think the cans are being underfilled. But descriptive statistically, more than half of them are underfilled. So what do you say? I don't know. It's up to you to say. It's your job to figure that out once you're in your careers. I would personally go with, let's look a little bit deeper and let's look at the outliers if there are any. Are they pulling the average? If they pull the average, maybe go back and test again. But anyway, that was, like I said, that was above and beyond the call of duty. All you had to do was to run these numbers right here. Hope it was helpful, and we'll see you in class.